I'm Ushma Neal with the Journal of Clinical Investigation, here for the next in our series of conversations with giants in medicine. If you or someone you know has Parkinson's disease, mental health issues, or other neurological disorders, medication can often help. The bulk of these medications have been established based on the work of neuroscientist Paul Greengard of the Rockefeller University, who worked out just how the brain responds to neurotransmitters, the chemicals that help the brain signal. The bulk of what most neuroscientists know today about neurotransmission, and specifically the dynamics of slow synaptic transmission, is predicated on the work of Paul Greengard. In the year 2000, he was awarded, together with Arvid Carlsson and Eric Kandel, the Nobel Prize in Physiology or Medicine. We look forward to hearing a little bit today about his background in science and his path towards discovery. Can you start by telling us a little bit about your upbringing and what led you to science?
I grew up in New York City. My mother died giving birth to me, and then my father remarried when I was 1 year old. He was a businessman, she was a housewife. They were both very anti-intellectual, and so I did not get the bug for doing scientific research at home. It was a very anti-intellectual atmosphere at home, and to a certain extent, possibly rebellion against that was what led me to be very committed to science, but I really don't know.
So as a result, you used the GI Bill, correct, to go to school?
Yeah, they did not want me to go to college, but fortunately I served in the Second World War and was able to get through college on the GI Bill, right?
What were you studying?
In college I studied mathematics and physics. And after that, I was going to go to graduate school, and I've been really planning to work in theoretical physics. That's what I was interested in. But this is almost immediately after the dropping of the atomic bombs on Hiroshima and Nagasaki, and I felt that was not an area I wanted to be very involved in, just because I thought there were better ways of spending my life than trying to destroy mankind. So I learned about this nascent field of medical physics or biophysics, and at that time there were two biophysics departments in the country. One was at the Lawrence Laboratory in Berkeley, which is involved in doing radioisotope studies in biology, and the other one was the Department of Biophysics at Penn, which is involved in studying the electrical properties of nerve cells.
So you started at Penn, but then soon followed the director to Hopkins, correct?
Yes, I was, during my first semester there, the chairman of the department, Detlev Bronk, moved to Johns Hopkins, A, to become president, and B, to start a new Department of Biophysics. He'd been the driver behind the development of the Department of Biophysics at Penn. And he took a few of us with him. And then I ended up doing a PhD degree there at Hopkins in biophysics.
With Keffer Hartline, who
Well,
later...
Keffer Hartline was the first scientist I worked with. He was a vision person who went on to win a Nobel Prize in vision. And I actually did my PhD degree with a man named, it was actually a joint degree between Frank Brink, who was a biophysicist, and a man named Sidney Kolowick, who's perhaps best known today for the series in Methods in Enzymology, edited by Kolowick and Kaplan. So it's kind of a joint thesis between the two. At the time I was in graduate school, what everybody in the department was doing was studying the electrical properties of nerve cells, and Alan Hodgkin came and gave this beautiful lecture And I realized he really made a very important advance, he and Huxley, in understanding the ionic basis of the nerve impulse, and I thought it may be a long time between that discovery and the next major advance in biophysics. So I decided it would be interesting to understand more about the underlying biochemical molecular properties of nerve cells. So I moved into the, basically, well, I guess you'd best call it neurochemistry in those days, or molecular neurobiology today.
I had read from your autobiography that accompanied your Nobel lecture that you marked that lecture by Alan Hodgkin as one of your first aha moments that helped you to shape the direction of your career.
Yes, that's true. I mean, he was a marvelous lecturer, a marvelous human being, and it was very inspiring. But it inspired me in sort of a negative way. I said, I don't want to be here anymore. He solved the problems that are solvable right now, and it's going to be a long time before biophysics can learn much more, and that turned out to be the case. So I turned to studying the biochemistry of nerve cells and their function.
Right. After you finished your PhD at Hopkins, you then spent several years abroad in England and in Holland. How did that time shape your path and your discoveries?
I spent a lot of time thinking about how the rapidly increasing knowledge of biochemistry could be applied to an understanding of nerve cell function. And it was a difficult period in the sense that biochemists were only interested in the brain as a source of enzymes. There are thousands of enzymes that are much more active in the brain than any place else, so you already had a highly active source of material to do enzymology. The people who were neurophysiologists were not really interested in the underlying molecular mechanisms. I went to a pharmacology department for 3 of the 5 years that I was doing my postdoctoral studies because they had both biochemical and electrophysiological equipment that one could use. And so, while I was there in the laboratory of a very distinguished scientist named Wilhelm Fehlberg, I was able to gain a lot more experience in both biochemistry and electrophysiology. Then I got interested in, well, I was approached about a position in a pharmaceutical company. I was very young, and they offered me this very senior position. And I thought it might be exciting to take my knowledge of basic science and apply it to new drug discovery. And so I worked for 9 years in a pharmaceutical company, which was called Geigy at the time, and then merged with Ciba and became Ciba-Geigy, and merged with Sandoz and became what's today known as Novartis.
So how did that time at Geigy shape the way that you did your research or how you thought about targets?
Yeah, that's a very excellent question. I think it did a couple of things for me. It gave me an education of the sort one might have gotten in medical school. At the time I was ready to do advanced studies, I decided not to go to medical school because at that time it was very much of a hands-on profession where the physicians really couldn't do very much for their patients. I mean, there were brilliant clinicians, but there was a very limited repertoire of tools they had. And therefore I decided to do a PhD, but I got the kind of education while I was in the pharmaceutical industry that a lot of which I would have gotten in medical if I'd gone through a medical school, because I learned much more about the biology of the body, and particularly of the brain there, what the major issues were, and began to think about ways of studying them. When I got out of that 9-year period, I went to, I did 1 semester as a visiting professor at Vanderbilt University with a man named Earl Sutherland who discovered psych-AMP, and that was very excellent experience. And then I moved to my first full-time position as a professor of pharmacology at Yale. And I was very interested, at the time, when I was a graduate student at Johns Hopkins, Sutherland was publishing these amazing papers on how hormones were producing their effects and showing it was through psychic AMP. And another line of study, Edwin Krebs and his colleagues have been studying protein phosphorylation and found that psychic AMP regulated protein phosphorylation. And so when after these 9 years of developing drugs and trying to develop drugs, central nervous system drugs predominantly, I returned to this interest in the biochemical basis of nerve cell function and leaned very heavily on those discoveries from the Sutherland lab and the Krebs lab to try to elucidate what's going on in the brain. And we were able to show that the enzymes which had been reported by Sutherland, the adenyl which makes psychic AMP, and he had shown that was activated by hormones, that we were able to, I guess the key advance I made was in considering the possibility that what Sutherland had been studying, namely how the endocrine system works, how hormones work on a distant target, such as with glucagon and norepinephrine on the liver and muscle, that might be applicable to nerve cells at a neurotransmitter released from a presynaptic terminal and activating postsynaptic receptors, which were hypothetical at the time, might be analogous. And we found the neurotransmitter sensitive adenyl cyclases in the nervous system, showed they were in the plasma membrane. So it became clear that this was a very analogous, that the nervous system responded to neurotransmitters the way the endocrine system responded to hormones, even though there's a millionfold difference in the distances.
And that must have been a rather heretical proposal to have at the time. That
it was. People said unkind things, like this is heretical and nonsense and that sort of thing. The interesting thing about it was that because it was considered so unlikely to be true, I had basically 15 years from about 1968 to 1983 to develop this story. And by the time people accepted it, my research group had laid a lot of the foundation of the molecular basis for neurotransmission. So we didn't have this ultra heavy competition. I've talked to other people who have the fortune of being recognized with the Nobel Prize. And in many instances, it's been the same thing. They've done something very unconventional, and nobody believed them for a while, and then it was shown to be true. And if you think about it, it's more or less the only way the thing could work. If you just did something that was very incremental, it wouldn't be worthy of a Nobel Prize. So it has to be almost invariably something that, occasionally there are different types of discoveries, but many of the discoveries were made where there was a paradigm shift, where somebody did something that people didn't accept because it was not consistent with the prevailing paradigm.
Now, speaking of that, I want to go back for a second and ask if there was ever a time when you had an encounter with a patient or a learning about a specific disease that caused you to alter the way that you thought about it, perhaps when you were at Geigy thinking about target discovery.
The only case where that is true, I've been doing a lot of work on Alzheimer's in the last 10 years, and well, maybe 15 years. And my wife's father had Alzheimer's disease. We used to visit him in this Catholic hospital in Connecticut, and I had a lot of time to observe him and the other patients in this Alzheimer's ward, and became more and more interested in the disease. And then eventually moved into it. We moved into it, there was a postdoctoral fellow in the lab named Sam Gandhi, who's now one of the leading authorities on Alzheimer's disease. He had just joined the lab as a postdoc, and about that time, the sequence of the amyloid precursor protein was discovered. This is the protein that is the precursor, the name implies, for beta amyloid. And it was discovered simultaneously in several research groups. And the sequence indicated that there were potential phosphorylation sites. And since what we were doing then, this is already in the 1990s, we're studying phosphorylation of proteins. Here was a protein which got or looked as though it would be phosphorylated, and it was, and so I got into that field. But my recent work, well, I guess if I can make a oversimplification, the first part of my career had to do with elucidating these signaling pathways by which nerve cells respond to neurotransmitters, and how nerve cells receiving signals from several different places could integrate that information and explain a lot of the electrophysiological responses. In the last 15 years or so, using that information, I became increasingly interested in studying the molecular basis for various diseases, because we now knew lots about the pathways that are involved. And so today, much of the work of our research group is dedicated to studies of depression, Alzheimer's disease, Parkinson's disease, and schizophrenia. And they sound very different, but these signaling pathways have a lot in common, and the techniques to study them have even more in common, and so that's where much of our activity is today.
So after your short stints at both Vanderbilt and Einstein, where you had the germinal seeds of some of these ideas, you spent 15 years at Yale working on some of the early basis for what you would later be lauded with the Nobel Prize on. What was that time like when you were first building your lab?
It was a very pleasant atmosphere, and even though my thinking was considered extremely unconventional by my friends and heretical by my non-friends, it was a very friendly atmosphere. I mean, the colleagues at Yale were all wonderful and had open minds to a large extent. And the funding was very much more ample then than it is now. And so I think there was more support for people with unconventional ideas at that time. And so I didn't really have any trouble raising funds. It was like post-Sputnik period, and during the 60s and 70s, it was a pretty good time to be in science in terms of getting support for one's work. And it's gradually gotten tougher and tougher over the decades.
So then in 1983, you moved to the Rockefeller, which has been your home for your scientific home since then. And you've worked not only on furthering neurotransmitter signaling, but have moved on to other topics that you mentioned, like Alzheimer's disease, et cetera. So what has the culture at Rockefeller done for the way that you have done your work?
One of the very attractive things about Rockefeller is its size. And this generates an atmosphere of collegiality. I noticed when I first went to Yale, it was very collegial, but the place grew enormously over the 15 years I was there. So by the end, it was more every man for himself and the devil take the hindmost. It was really every man for himself, because there were basically no women there. And then when I moved to Rockefeller, it was also small, and it stayed relatively small. And so people feel a responsibility to help each other. I mean, whenever I've needed help in some technical issue or some other scientific problems that I had, I've never been rebuffed by any of the faculty there, and I feel the same way of wanting to help my colleagues. And like I said, it's really, I think it has a largely to do with the size of the community with which one identifies or finds oneself.
And I imagine it's also, given the proximity to these other experts, Rockefeller has very likely also led you down different pathways of discovery.
Yeah, absolutely. Because you tend to know more about your fellow scientists. I've been greatly influenced. Nat Heinz was a professor there, and I worked on something that I think neither of us would have worked on alone, which has really been a very important advance in understanding how nerve cells work. This involved determination of all the proteins expressed in each individual nerve cell type in the brain. And between Nat's brilliance in molecular biology and my knowledge of certain types of brain function, it's been a very productive period.
So in the year 2000, while you were a professor at Rockefeller, you were awarded the Nobel Prize in Physiology or Medicine.
Yes.
What was it like to go to Stockholm to accept that award?
It was very pleasant. I'd been told for decades, literally 20 years, that I was going to win a Nobel Prize that year. And after a while, you don't believe it anymore. And somebody had told me on Friday evening that I was getting it this year. It had never been that close to the announcement. And then Monday morning, the announcement came. And our daughter was staying with us in our apartment. And somebody called at 5:15 in the morning, and we'd gotten to bed very late. And by the time I picked up the telephone, I heard my daughter saying, "But he's sound asleep. Do you really want me to wake him up?" And he said, "Well, my name is Hans Jornvall, and I'm the secretary of the Nobel Prize Committee." And I said, "It's okay, I'm awake." So that was how I first learned about it.
Now, you used your share of the winnings to endow a prize in the name of your mother, the Perlmeister Green Guard Award for Women in Science.
Yes.
Can you tell me why you decided to use your honorarium for that prize?
I had seen a lot of discrimination against women. When I grew up, it was pretty much universally accepted that women were inferior by both men and women. It's hard to believe now, but almost everybody I knew thought men were smarter than women. And it took a long time and a lot of fighting by a lot of courageous women and some supportive men to put that idea to rest. And having seen all this discrimination, I thought it would be nice to do something to help champion these women who are still struggling and still are today. It's incomparably better than it was, but there's still a lot of discrimination. So that's why I did that.
In addition to the prize for the furthering of science, especially with women, I have a close female friend who trained in your laboratory as a postdoc, and she mentioned to me that you were an excellent mentor. So how do you approach mentoring of young trainees?
I don't have a formula. A number of former students have said they learned a lot. I've been told by a number of students that the most unpleasant experience of their life was writing a manuscript with me. They thought it was sheer hell. And then they would tell me 15 years later, you know, I had no idea how much I learned. So I don't know, this mentoring thing, I think one can get more credit than one deserves. For example, I've had the pleasure of observing many of my former students and postdocs become leaders in American neuroscience, the world neuroscience. I don't think that I was brilliant in teaching them how to be such good scientists. I think that the younger generation tends to have an instinct about what the important new directions are. And so many of these students said, oh, that's the future and I want to do that. So they came to study with me, and since they were brilliant to begin with and came to study with me, they went on to very successful careers. In other words, I think the mentors tend to get more credit than we should for this. I mean, the student should get more credit for having picked that person as his mentor or her mentor.
Now, do you advise your trainees to go for unconventional ideas or things that change the dogma like you did when you were younger?
No, I don't do that. I think the best training that I give is from their observing how I approach a problem, how I think about a problem. And I was rather frustrated in my 9 years in the pharmaceutical industry because I had to do a lot of things which I didn't think were very important, because these companies are like an army and you do what your boss tells you to do. I became very aware of how time is flying by, and it's really important to work on the most important questions. And I don't generalize that to my students, but I say I think this is what's more interesting than that. This is the more important issue. And I think they probably pick up. If I do anything for them, that's probably what it is and how it's done.
Your Wikipedia page, have you read it in recent memory?
I've never read my Wikipedia page. I've been too busy, I haven't had time.
Well, your Wikipedia page lists a rather entertaining bit of trivia about you, and that is that you won first place in a potato sack race at a New York Boy Scout jamboree when you were younger.
Yeah, they had like the troops, and then the troops from Queens, and then the troops from New York City. I mean, there was like successive things like in a tennis tournament with, the quarterfinals and the semifinals and the finals. And I really won that, and it gave me great joy. I not only won it, I won it like unbelievably compelling victory. And the joy I got was indescribable because I was very small when I was young. And I was, like, in those days you'd go to the nearest neighborhood lot and the kids would pick teams, there'd be two captains. And the only way I ever got to play is if there were an even number of kids. If it was an odd number, I was always the one left out. And that was true in baseball and football. And so to find something that I was skilled at, which just requires coordination while you're hopping. Do you know what potato sack races are?
Oh, yeah.
They still do them, I guess. Anyhow, so I got enormous joy out of that. And like I said, my competitor barely had left the starting line by the time I'd won. I had all kinds of drive to win this thing.
According to your Wikipedia page, it's also interesting to hear a little bit more about your family, who's also been profiled in the New York Daily News as a family of high achievers, wherein your wife is a very famous sculptor, your sons both have PhDs, and your daughter is a big player in television media. So the Scrabble games, I imagine, at your house must be rather intense, and the after-dinner discussions rather entertaining.
We seem to be too busy talking about other things to play Scrabble. It's intellectually very active atmosphere, but Scrabble is not part of that.
The New York Daily News article mentioned that it's not that the discussion's probably more highbrow, you spend much of your time deciding who's doing the dishes.
that we spend a lot of time deciding who does the dishes between my wife and me? That's not true. I haven't ever done a dish. I advocate women's rights, but not at home. No, I'm so incompetent manually that she doesn't let me do. I wanted to cook when we first were together, and she got rather impatient because she's a very good cook and very, very fast, and I was slowing her down too much. So I do other things, but cooking and dishes are not. I'm not proud of it, that's just the way it evolved.
So on the list of other vocations that you could have possibly contemplated, being a chef is not one of them then?
No, I love cooking, and I think I'm pretty good, but she's much better.
Now, have you ever contemplated a different career path?
Recently, my granddaughter, who's an attorney, and is trying to search out what exactly she would like to do in the long run, asked me what I would do. And I thought about it. I'd like to be a constitutional lawyer. And in my wilder dream, either a professor at a university of constitutional law, or in my wilder dreams be a Supreme Court justice. And in my wildest dreams be the Chief Justice of the Supreme Court.
It's been a delight to hear about your path and your thoughts and the way that you approach science, and we really appreciate you taking the time.
Thank you.